going to be part 2 in simplifying rational expressions, which just gives us more practice than what the lesson was previously. Here we have a binomial divided by a binomial, and anytime you have binomials or trinomials, we want to see if we can factor at any. On the top we have two terms. It can't be the difference of two perfect squares because it's not a subtraction sign. So is there a greatest common factor? X cubed plus 4x both has an x, so we can factor out an x. If we divide each term by x, what that leaves is x squared plus 4. So that's what we have on the top. On the bottom, again, we have two terms, but we do have a greatest common factor of 2. So if we factor out a 2 and we divide each term by 2, that leaves us with x squared plus 4. So what did that leave us? Here it is. Oops, I thought I had it there. On the top we had x times x squared plus 4, and on the bottom we had 2 times x squared plus 4. This binomial is the same as this binomial, so they cancel each other out. That leaves x divided by 2. So more practice doing what we did yesterday. Now let's check for the difference of two perfect squares. Well, 6 is not a perfect square. So what is the greatest common factor for 4s to the 4th minus 6x cubed? We can factor out a 2 and an s cubed. I'm going to go ahead and do it down here. We can factor out a 2s cubed. Now if we factor that out of each term and we divide each term by 2s cubed, not squared, 2s cubed, what do we have left? We have 2 and 1s, 2s left from the first term. In the second term, these cancel out, so you're left with 3. On the bottom, greatest common factor of 2s cubed minus 3s squared. If you look, what do you think the greatest common factor would be? It is s squared. So now we're going to divide both terms by s squared, factor it out. That leaves us 2. This cancels out 2 of these, so that leaves us 2s in the first term. And these cancel each other out, so it leaves minus 3 in the bottom, which is really convenient because now we have two binomials that can cancel each other out. Now we have, outside of the binomials, we have two monomials. On the top we have s cubed. On the bottom we have s squared. So 2 of these cancel out 2 of these, which leaves 1 of the s's left. So all we have left is 2s. Everything else is gone. At the top, do we have the difference of two perfect squares? Everything's a perfect square except the r, so that is not the difference of two perfect squares. What is the greatest common factor? The greatest common factor is 6, so we're going to factor it out. And now divide both of those terms by 6. That leaves us with r minus 6. The bottom is already factored for us. Isn't that nice? And then we have the same binomial on top as on the bottom, so they cancel out. And that leaves us with a 6 on the top and an r plus 4 on the bottom. On the top we have a trinomial. This happens to be a perfect square trinomial, if you recognize it. If not, you would have to use your reverse FOIL. To recognize a perfect square trinomial, is this a perfect square? Yes, it's t. Is this a perfect square? Yes, it's 5. Then you multiply the two terms, 5 times t, which is 5t, and double it. If it's the center term, it's a perfect square trinomial, so it would just be factored t plus 5 and t plus 5. If you didn't know that, then you would have to do the reverse FOIL, where 25, you think of factor pairs for 25. There's 1 and 25 and 5 and 5. So there's our plus 5 when we factor it. On the bottom, we have two terms. It's not the difference of two perfect squares, but we do have a greatest common factor of 7. So we're going to factor out 7. When we divide both terms by 7, that leaves us with t plus 5. So what can we cancel out? A t plus 5 on top and a t plus 5 on the bottom. That leaves us with t plus 5 divided by 7. Little more practice. Now there's one in particular on your assignment today, probably the hardest one of all because it's a factoring method that we haven't reviewed in the last few days, so I'm going to look at it with you. This is your assignment, and on number 15 we have a we're looking right here. We have a trinomial, and the leading coefficient is not 1. So do you remember how we factor that? We're going to make 4 terms. If you remember, we're going to keep the first term, which we call slide the first term. We're going to keep the last term, which was a plus 5. And we're going to divide this middle term into 2 terms. To do that, remember we multiply the A term by the C term. That makes 10. And we think of factor pairs for 10, where we can add the 2 factors together to make the middle term, which is 7. Well, we have 2 and a 5, so we can say 2n plus 5n, when we add those together, is equal to 7n. And when we multiply 2 times 5, we get the 10, which we were looking for. So we now have in the center 2n plus 5n. So we made 4 terms out of 3 by sliding the first one and the third one down and dividing the middle term. Now remember, we solve by grouping. We're not done yet. We have 4 terms. Anytime we have 4 terms, we factor by grouping. So we look at the first group. The greatest common factor is 2n. What is left is n plus 1. With the next one, the greatest common factor with the next grouping is 5. So we factor out a 5, and that would leave n plus 1. One more step. Look for the magic. On the outside, we have 2n plus 5, and we have n plus 1. So this was a review of factoring with 3 terms when the leading coefficient was greater than 1. Took a little steps there, but we got her done. On the bottom, we have a binomial, and it's not the difference of 2 perfect squares, so we're going to have to see what the greatest common factor would be. And the greatest common factor for that would be 3n squared. So we're going to factor out a 3n squared. We're going to divide each term by 3n squared. And what is left? We have 2n, and then we have plus 5. Now that we have everything factored, I'm going to put a square around it. So this is what we have now that we have everything factored. So now what can we cancel out? Well, we have the same binomial on top as we have on the bottom. And that leaves us with on top n plus 1. Where can I write this? N plus 1. And on the bottom we have left 3n squared. I did that one with you because we needed to review how to factor a trinomial when the leading coefficient was greater than 1. Make 4 terms, factor by grouping. We could just randomly do one more of these. I don't know which one I think would be the hardest one. So let's just randomly pick number 8 for fun. Let's just do one more together. A squared plus 9a plus 20 is a trinomial where the leading coefficient is 1. So we use our reverse FOIL. So think of factor pairs for 20. 1 and 20, 2 and 10, 4 and 5 I think would be our best bet. So we're going to have a plus 4 and a plus 5. Let's check it with FOIL. A times a is a squared. Then we have 4a times 5a, or 4a plus 5a, which is 9a. And then you have 4 times 5, which is 20. I checked with FOIL. On the bottom, we actually have the difference of 2 perfect squares. So we take the square root of a squared, which is a. Take the square root of 25, which is 5. Now we write it a minus 5 and a plus 5. What can we cancel out? On the top and the bottom, we have the binomial a plus 5. So that leaves us with a plus 4 on top and a minus 5 on the bottom. So that was good practice because we had practice with the difference of 2 perfect squares. Just remember, if you have a binomial and there's a subtraction sign, like the next one, but it's not the difference of 2 perfect squares, you're just going to pull out the greatest common factor. So good luck with practicing more on simplifying rational expressions.